In this problem, we're asked to write down the expanded form of the Fibonacci sequence based on the recursive form of it. So here's this little recursive formula. I have that the nth term should be given by the n minus first term plus the n minus second term. In other words, the next term always comes from the sum of the previous two. And you may be able to do this very informally by just using that statement. The next term is always the sum of the previous two. But I want to illustrate how you would sub in values of n to generate these terms. Maybe in a case where the formula was nastier than this, you would have to get more formal about it. So we're told find the first 6 terms of the sequence, and we're already given the first 2. I may actually go all the way out to A6 just to illustrate the pattern a little bit better. And all I'm going to do is plug in n equals 2 into this recursive formula. And that gives me that A2 is equal to A sub 2 minus 1, that's A1, plus A sub 2 minus 2, and that's A0. So that's sort of formally how you handle it. You sub in n's to generate new terms. And A1, of course, is 1, and A0 is 0, so A2 is 1. Then I go to A3. Again, handling it somewhat formally, I would sub in n equals 3 into the recursive formula, and I get that A3 is A2 plus A1. That's just the previous 2 terms again, and that's 1 plus 1, and that's 2. A4, you would sub in n equals 4, A sub 4 minus 1, right? It's A3. A sub 4 minus 2 is A2. And my previous 2 terms are 2 plus 1, and it gives me 3. And then I can relax that formality a little bit and say, okay, the pattern is clear. Just take the previous 2 terms and add them. So that's 3 plus 2, that's 5. And I'll go all the way to A6. That's A5 plus A4. And that's 5 plus 3. And that's 8.